welcome back to our tutorial session. My name is Filippo Martinoni, and in this tutorial I will present you how the role of the different player works. So a role is defined as a state machine, as a finite state machine. What is a finite state machine? A finite state machine is a setup, let's say, where we have different state, and from one state we can change state, but we cannot go everywhere, so we cannot change in every state, but we have somehow to follow an order. So to make you an example, if we take a traffic signal that can take the color green, yellow or red, so if for example we are in the state green, we cannot switch directly to red, but in between we are going to be green, yellow and red. This is just to give you an idea, so that if here is green and here is red, we have to go through the yellow state in order to come to the red one. So we cannot just go from the green state to the red state. In our case is the same. So in general we have an initial state, then we have the common transition. The common transition is like some condition that are at every iteration check, and from here we can say, so for example, if we are in state 1, but on the common transition we say if the variable chi is true, then go directly to state 3. So let's say that we are here and suddenly c become equal to true, so we're going to switch directly here. Else what happens? So from our initial state, we always check every time some condition and we perform some action. If these conditions are fulfilled, then we're going to switch state. So let's see an example on that. This is taken from the Human Code Release 2013. I'm sorry that I have to use the big screen now, but else it will be a little bit uncomfortable. So a state machine in normal way is defined like that. So there is option, the name of the option. In our case, if we speak about a role, could be for example defender, could be goalkeeper, could be striker. We have here the common transition, and here are not shown. Then we have the initial state, so the state where the whole role start. As I say, we have this transition. This transition is checked every time, and if some, in this case, Boolean expression are fulfilled or not, we use this goTo, and this goTo send us to the next state. As you can see here, we define the second state and third state as state. Okay, so this means that if this Boolean expression become true, then we switch to the second state, so we come here. Then in between that, we check at every iteration if the condition are fulfilled or not. We perform some action. Okay, later on I will make a more concrete example. So let's say that we are on the initial state, so we are in the first state. We provide this action. As soon as, for example, let's say this Boolean function will return true, we go to the third state. In the third state, we perform this action until this Boolean expression will become true. In that case, we go to the first state. In the first state, we perform this action, we check this condition, and we go further like that. So just to show you once more here, so we say that we have this common transition that work every time, that I didn't show you now. So we start from the initial state. If some conditions are fulfilled, we go to, for example, to initial state 1. From state 1, if some conditions are fulfilled, we can come to state 2, else maybe we can come to state 3, and so on. However, the number of states is finite. Now to come to our code, I make you an example on the pass player. So this pass player is just implemented for the simulation of the pass. How does it work? For example, here we have the option. Here we gave the name of the state of the role that we want to give. In our case, is pass player. We can also give some other parameters. Then as we initialize, we start with the state. We want first of all to find the ball. So here we say just wait a moment, just wait, I guess it's 0.1 second, but I'm not sure. After that, just go to search. In the state search, what we do, we search for the ball. So if the ball is seen, as you can see, the action is search for the ball. As soon as this condition tells so to find the ball. So and if the ball is found, then we go to the pass. In the state pass, what we do, so we have that these are two conditions. Actually, these are already implemented. I would advise you so to press Ctrl, click on both of them, and look what they exactly mean, because I can tell you, for example, now I lose the pass player. It's gone. So this action is done. It means that, for example, if you want to kick a ball, as soon as, so let's say that here we have the ball. No, this is the ball, let's say, and as soon as the player reach the ball and it start to perform the kick, this action done flag will be set to true. So I would advise whoever to make some tests, because I'm not sure exactly when this flag is set to true or not. Action aborted. I never see it in function, but I think it means that if the robot will fall down or something like that, this flag will become true. However, in the pay state, what we do, we perform the action pass. The action pass is another state machine. What is important to say is, from what I make some tests and I found out that this is true. However, I would advise you to check. So here we are in the state machine, and here we say, okay, as action, go in this other state machine. However, if for some reason this action will become true one of the two, even if here inside we are in any state, so we are going to come back from the past state machine, come in this state machine, and then change to the state search. So once more, if we are here inside, we are for example, in the state pass front. What will happen if the condition that I showed you before, so if this condition will become one of these two, will become true, and therefore we, according to this state machine, so the basic one, we have to go to search, so the state machine pass will be interrupt and we go directly to search. In the pass state machine, what happened, for example, I will explain how this is structured in the pass video. However, we have here a common transition, and here in the common transition I say, okay, if my distance to the ball is bigger than the parameter, is the same in which state you are, but you have to go to the pass decision state. In the pass decision state, for example, according to which condition are fulfilled, in this case, because we want to perform a pass, if the pass is forward, we are going to the state pass front, so that we kick the ball in the front. If the pass is backward, we also go to pass front. If the pass is lateral, we go to the state pass lateral. Normal ways, here I'm not sure, but from what I get, we define the variable here over, and we initialize the variable here. Here I didn't initialize them here, this because it's like a constant, but I guess it could be for you a good stuff to have a look to the other role, in order to see how they are implemented to maintain a order on the wall code. Last thing, where are implemented this stuff? So if you go under module, behavior control 2013, option, you have the role. This role, as I said, defender, keeper, and so on, is the state machine. of the role, and then we have the skills. So the skills are also state machine, but they can be also a state machine with just one state, but these are just skills. So normal ways we have the role, and the role will call them the skills. This is all for the role. I hope you get a clear idea how does it work. I would advise you, however, always to have a look in order to understand better how does it work. And if you want to implement a new role, a new skills, or a new player, I would advise you that you copy paste the past player. That is very the easiest role that you can have. So where you just say, okay, if you don't see the ball, look at the ball, else do something other, so this action, and then try from here to implement something more difficult and more complex. You can always add some state, but this is since it's a very basic structure and it should work, so I mean it work, I would suggest you that it's easier if you start from here. Thank you for your attention.